Okay, buongiorno ragazzi. Today I will explain you how to solve second, third, and the fourth problem from the fourth class. So today we'll speak about elasticity. Elasticity, by definition, elasticity of y by x is the percent change of y if x changes by percent. So you can count elasticity for everything. Elasticity of demand by price, cross price elasticity, elasticity of demand by income, and so on. So what that means, this is the reaction of one variable by the change in another variable in percent. So let's do number 2. We have the demand 12 minus P per unit price of the product, and we should count elasticity in each point and total revenue. First of all, we can count total revenue. It's easy. Revenue is price multiplied by the quantity, how much we want to buy. So here will be 11, here 9 over 3, 27, 35, 35, 27, and 11. So you see, here is the increase in total revenue, and here also. So next we can count elasticity. We can write down elasticity of demand by price. So this is how our consumers react on the change in price of the product. We can open it. It is the quantity demanded after change minus the quantity demanded before change of price over quantity before the change multiplied by 100% over price 2 minus price 1 over price 1 multiplied by 100%. We can divide by here everything 100 and revert and write down. This is the change in quantity demanded over the change in price without percents multiplied by the first price over the first quantity demanded. So, and by this definition, we will count elasticity. We cannot count elasticity in the first point because we do not know the previous price and previous quantity demanded. So we do not know Q1 and price 1. But in the second row, we can count. So let's find it here. So elasticity will be Q2, new quantity demanded 3, before it was 1, over the change in price. Price now is 9, before it was 11, multiplied by the first price over the first quantity demanded. And here will be 2, here minus 2 multiplied by 11. So this minus 11. Elasticity of demand by price is always negative because the rule of demand, higher the price, the lower quantity demanded, the less we want to buy. So next row, elasticity will be 5 minus 3 over 7 minus 9 multiplied by 3. No, multiplied by price, first price. First price was 9 over first quantity was 3. So here will be minus 3. Then next, where to count? Okay, here, elasticity. 7 minus 5 over 5 minus 7 multiplied by the first price. The first price was 7 over the first quantity 5. And this is minus 7 over 5. It's minus 1.4, if I'm not mistaken. 2 over 5, yes, 4. Minus 1.4. Mm-hmm. Mm-hmm. 7 over 5. Yes. Next, I will erase. So here, elasticity 9 minus 7 over 3 minus 5 multiplied by 5 divided by 7. And this is, let's count, 5 over 7. It is 0.7 minus 0.7. And last, elasticity equals to 11 minus 9 over 1 minus 3 multiplied by 3 over quantity, first quantity 9. And this is 1/3 minus 1/3 or minus 0.33 approximately. So, okay. As you see, what is connection? When the total revenue increases, we have by module lower and lower elasticity. And here we have higher and higher elasticity. So what conclusion we can make? If we have linear function, the highest total revenue will be when elasticity equals to -1. So we can draw it like this. Here price, here quantity, our demand 12 minus price. So this is demand, here 12, here 12. In this point, elasticity equals to minus infinity. In the center, elasticity equals to -1, as you know from the lecture. And here, elasticity equals to 0. So let me put it down. And draw the next graph, total revenue. How to draw? Total revenue is inverse demand function multiplied by quantity. So this will be 12 minus quantity multiplied by quantity. Or it is 12q minus q squared. This is quadratic function, graph parabola branches down, and the highest point is minus b over 2a, and this will be minus 12 over minus 2, 6. So when quantity equals to 6, total revenue is maximized. So how our parabola looks like here 0, here 12, these are roots of a quadratic equation, and maximum is in the center, 6. Here, total revenue. So what we see, if we allocated on the elastic part of demand, elastic part, strong reaction of consumers for the change in price, then for increasing total revenue, what we need to do? We need to reduce the price. Yes? What that means? As one more time, total revenue is price multiplied by quantity. If we will decrease the price, people will react strongly. So a lot of people will come to buy our product. That means the total revenue will increase, as you see. And another part, inelastic part, low reaction of consumers for the change in price. Inelastic part. Here, to increase total revenue, we need to increase the price. Why? Because here, total revenue, as always, price multiplied by quantity. If we will increase the price, not many people will switch to another product because reaction is low. So that means that total revenue will increase. So this is an interesting fact about elasticity of demand by price and total revenue, connection between them. So this was number 2. Next problem. In the next problem, no, we also need to do point B. In the second problem, suppose the demand curve shifts to the right with 2 more units sold at each price. Is the new demand curve more or less elastic than the old one? So let's draw. So here is 12, 12. And now for each price, we want to buy 2 units more. So now it will be 14, 14. Elasticity was equal to -1 in the center. Yes? And now the center is here. Elasticity here equals to -1. So what that means? For each price, for each change in the price, you see, now elasticity goes down by module. It means, for example, for this price, before elasticity was -1, and now we are in the inelastic part. That means that demand now is less elastic. Because we're speaking about the reaction of consumers for the change in price. And that means for each price, the demand becomes less elastic. Okay, this was point B in number 2. Next. I will copy it, put it here. Let's read. An estimation of demand facing a particular firm produced the following information with regard to the elasticities of daily demand for product X. So, the elasticity of good X by the price of good X equals to -2. What that means? That means that the demand is elastic, strong reaction, because by module, the reaction is bigger than 1. So elastic demand. And by definition, it is the change in quantity demanded in percents over the change in the price of good X in percents. Okay, next. Elasticity of demand of good X by the change in income of our consumers. It is equal to 1.5. What conclusions we can make? First of all, definition, it is the change in demand for good X when our monetary income changes. First, we can say that it is positive reaction. That means that higher our income, the higher is demand for the product. And we can call such product as normal good. Also, our elasticity of good X by monetary income equals to 1.5 is bigger than 1. So the reaction is strong, and we can call such product not only normal, but also luxury good. You can do like this. Here, elasticity of good X by the change in the monetary income, here 0, here 1, and something like that. So if elasticity is less than 0, we call such good inferior. If elasticity of demand by monetary income equals to 0, it is independent good. Yes. If elasticity equals to 1, we call it unit elasticity. If we have positive but low reaction of consumers, our good is necessity good. I think my grammar is not so good, but anyway. And if we have strong but positive reaction, this good is luxury good. Also, we say that if we have positive elasticity of demand by the change in monetary income, we call such good normal good. I hope this scheme will be useful for you. But this is only true when we speak about elasticity of demand by the change in income, not price. Okay, next. Here is cross price elasticity. So elasticity of demand by of good X by the price of good Y of other product, and it is now minus 0.8. First of all, definition is the change in the demand for good X in percents when the price of good Y changes in percents. So what we see, it is a negative reaction. That means that the higher the price for good Y, the lower the demand for good X. We have two options how to call such goods: complements or substitutes. For example, the higher the price for automobiles, for cars, the lower the demand for fuel, yes, for gasoline. So gasoline and cars, they are complements to each other. So if cross price elasticity is negative, we call such goods X and Y complements. And elasticity of good X by the price of good Z is 0.5 positive. It is the change in quantity demanded for good X by the change in price for good Z in percents. And it is positive. That means, for example, the higher the price for Coca-Cola, the higher the demand for Pepsi. Such goods, X and Z, are substitutes. So these are our conclusions. And now let's do number point A in our task. Suppose that at the current price, the firm is able to sell 1,000 units of good X per day. So X1 equals to 1,000 units. Had it cut the price X by 1%, how many more units of good X would it be able to sell daily? So the change in price in percents now is cut the price. So minus 1%. Yes, let's look at elasticity of demand. Elasticity of good X by the price of good X is minus 2. And it will be equal to the change in quantity demand to X in percents over the change in price. So here minus 1%. Multiply, solve this equation, and from here we will find that the quantity demanded will increase by 2%. So X2 will be equal to how much? 1% is 10, so 2% 20. New quantity demanded will be 1,020. It was point A. Point B. If this firm wanted to increase its revenue, would it rather make sense to raise the price of X or lower it? What we see, we were speaking about it in the previous task. Elasticity of good X by the price of good X equals to minus 2. It is elastic part of demand. That means strong reaction of consumers by the change in price. Total revenue, one more time, is price multiplied by quantity demanded. And what we need to do to increase total revenue? We need to lower the price because we will have strong reaction of consumers and total revenue will increase. Or we can say like that. If the change in total revenue in percents is the change in price in percents plus the change in quantity demand to good X in percents. And would rather make sense to raise the price of X or lower it. For example, if we lower the price by 1%, we know that quantity demanded will increase by 2% according to elasticity, and the total revenue will increase by 1%. Minus 1 plus 2, it's plus 1%. Good, it was point B. Point B. Next point B. Given the information about elasticities of demand for X with respect to the price of Y and Z, gross substitutes, gross complements, we answered it that X and Y are complements and X and Z substitutes. Good. It was one more point B. This I. This is second. Okay, if consumers' incomes increased, would they buy more of good X or less of it? We answered this. They will buy more of good X, and we called such good normal good. Then, would the budget share of good X rise or fall? What means budget share? Budget share is the share of your income that that you use for buying this good. So let's see, budget share. So our spendings on good X is the price of good X multiplied by the amount of good X. So these are our spendings on good X. And if when we divide by our monetary income, this is budget share. For example, it can be 1 or 0.5 or 0.2, 20% of our budget share we spend on good X. Okay, what we can say? If consumers' incomes increased, would they buy more of good X or less of it? More of good? Would the budget share of good X rise or fall? How we can write down the change in budget share in percents. It is the change in price of good X in percents plus the change in the demand for good X in percents minus, because it's in the lower part, minus the change in monetary income in percents. So what we have, budget share of good X rise or fall, income increased. So let's suppose that the change in our monetary income is plus 1%. What we can also say, the price of good X doesn't change. So this change is plus 0%. And according to elasticity, the change in, in the demand for good X will be how much? Plus 1.5%. Plus 1.5%. So let's count. This will be plus 0.5%. So budget share will increase. Or you can say like this. Monetary income increases, price constant, and the demand increases more because it is elastic demand by monetary income, 1.5 reaction, greater than 1. Okay, it was point number 3. Good, and let's do number 4. I will copy it now. Let's read. Forestry economists have found that short-run demands for softwood are very price inelastic. The cross-price elasticity of demand for British Columbian softwoods with respect to softwoods from other places is quite high, and the cross-price elasticity of demand for softwoods with respect to other woods is positive, but not as high. How can we rationalize these facts? Here are elasticities. In the short run, we can write down like this. So, demands for softwood are very price inelastic. Price inelastic, that means that the elasticity of good X by the price of good X, let's say, yes, for softwood, is less than 1, inelastic. That means that it is hard to substitute any softwood with something else in the short run. We have not so many time to substitute with something else. Next. Cross-price elasticity of demand for British Columbian softwoods with respect to softwoods from other places is quite high. That means that elasticity of, okay, let's say it be British Columbian softwood by the price of other woods is quite high. So by module, it is greater than 0. And without module, it is also greater than 0 because wood from British Columbia and wood from other places, they are substitutes. And it is, and they are close to perfect substitutes because elasticity is quite high. Let's write down that X is softwood from British Columbia and Y softwood from other places. Then what else? Cross-price elasticity of demand for softwoods with respect to other woods is positive. Is positive, but not as high. Elasticity of softwood by the price, example Z, it is wood. We can say it is greater than 0, but not as high. So Z, if Z is other wood or other woods, that means that softwood and other woods, they are imperfect substitutes. They substitute each other, but the demand is not so elastic. So they are imperfect substitutes. So these two materials are not similar. Yes, but softwood from British Columbia and softwood from other places, these are this is the same material. So the cross-price elasticity is higher, quite high. Okay. Point B. British Columbia happens to be very productive in producing high quality softwood timber, old forests, clear wood. This means that for a hectare of land, you would harvest more timber in British Columbia than in, say, Amazon rainforest. Recently, the province of British Columbia has started to set land arise from logging. This reduction in supply should raise the equilibrium price of softwood. Given the elasticities, what would happen to the amount of wood consumed for other countries? Okay, so we increase the supply for our softwood. We know what will happen. The lower the supply, the higher the price of softwood. We can show it like this. This is the demand for good X, here price of good X. This is the supply of good X. And now we supply less. So for each price, the quantity supplied will be lower. So this is supply for good X prime. And you see that optimal price will go up. What we also know? We also know that softwood from British Columbia and the softwood from other places, they are substitutes. And if the price for softwood in British Columbia now is higher, we will switch to the softwood from other places. That means that the demand for softwood in other places, from other places, will increase because elasticity of softwood from other places by the price of good X is positive, as they are substitutes. C. In what sense are the friends of British Columbia forests also enemies of the Amazon rainforests? Let's write down C. Friends of British Columbia forest equals to enemies of the Amazon rainforest. Okay, what friends of British Columbian forests want to do? They try to reduce the supply of such softwood to protect. So, friends of BC forests try to decrease the supply of this softwood for protection. And that means, because these two softwoods, they are substitutes, that means that the demand for Amazon rainforest softwood will increase. And that means that quantity that will be sold of this wood will increase. So it's bad for Amazon rainforests because more bigger area of such forest will be cut. So this is bad for Amazon rainforest. Because from the previous point, if the supply for good X increases, that means the optimal price for good X will increase, and we will switch to another softwood. Okay, that's all. Thank you.